Now let's actually put this hood through its paces. One of the things that I'm not sure if you can pick up or not is the sound level. The sound level is noticeably higher because it is a high pressure blower designed to move a lot of air. So let's see exactly how much air we're removing on our first test, which is that standard 4 foot of 8-inch ducting. You can see 600 CFM hood is what this is advertised at. And you can see with 4 feet of ducting, it's performing at about 610 CFM. So my colleague is now going to hook up our additional 2 90-degree elbows and 10 feet of ducting for roughly 30 equivalent feet of ducting. Much more in line with what you'd see in somebody's home. You can see with that additional ducting, we're now performing at about 580 CFM roughly. And now my colleague is going to put on our roof cap. Again, much more in line with how you'd see a hood actually installed inside your client's home. And you can see, brings it down to about 540 CFM. So I'm actually going to turn this hood off for a moment just so I can come through a little bit better. So our high pressure blower did exactly what it was supposed to be able to do. It was supposed to be able to overcome a little bit more restriction. Started out at 610 CFM with 30 feet and the roof cap, performed at about 540 CFM. Noticeably louder. Again, you've worked with your client, you've looked at their cooking application, whether it's a range top or a cooktop or a slide-in, pro style cooking, and you've spec'd out 600 CFM for the range hood. Your client is getting 525 all the way up on burst. Means they're going to need to run their hood on medium, high, and burst much more often than a hood that would be performing at 600 CFM.